It's on YouTube. I'm basically a YouTuber. My kid thinks I'm the coolest person ever. So if you watch this question, if you see this question, you have this to start with. 2 to the power 3 times 2 to the power 4. What we're going to do is we're going to take each of those powers, because there's 2 powers there, and we're going to break them apart. So I'm going to start with the first one. 2 to the power 3. My computer's doing wonky things today. 2 to the power 3. In factored form, that would break apart to be 2 times 2 times 2. 2 to the power of 4 would break apart to be 2 times 2 times 2 times 2. The reason why we would want to break it up into factored form is so that you could then combine these into one power. So what you really have here now is 2 times 2 times 2 times 2 times 2 times 2 times 2. You have 7 2's multiplied together. Instead of writing it like that, what would be a way more convenient way to write it? 2 to the power 7. So that means I've gone now from 2 powers to factored form to 1 singular power. That's the way that we'd want to write it. That's called simplest form, when you combine them together like that. If you look at the one, yeah.
Could you just do the math for that one and then?
Yeah, you could. So like what you were doing was kind of right, but this is trying to make a different kind of point. But what you did was right. It just wasn't what I was going to do. Yeah. If you look at the next one, we're going to do the same thing. We're going to write it in factored form. So if you look at the first guy, we have 8 to the power of 3. That means 8 times 8 times 8. Then we have another 8 there. If there is no exponent on something, what's the exponent?
8.
The base is 8. Yep. What's the exponent on it? 1. Right, there's an invisible 1 right there. That means we just have 1 8. Looking at this, I can now write this in simplified form. I have 8 times 8 times 8 times 8. That's 8 to the power of 4. This idea and breaking it down the way that I've broken it down should help lead us to something. And it's going to lead us to the conclusion that if you have 2 powers that you're multiplying together, you could write them as 1 power. And the way you write them as 1 power is there's a shortcut. Is you're just going to add the exponents. If you look at our original questions, if I look at the exponents, 3 and 4, 3 plus 4 equals 2 to the power of 7. So that means when you're multiplying exponents or multiplying powers, you can add the exponents to make them 1. The question below does the same thing. Our exponents are 3 and 1. If you were to add those together, you get 4. If you look at our exponential form, you have 8 to the power of 4. That's going to be our first exponent law. Down here we can fill in the blank. It says, notice that the exponent and the answer is the addition of the exponents in the question, and that the base didn't change.
Yeah. I've first read this. Like, am I doing this right?
Yes. Can we get for a second? So if you're looking at those, you can look at the next 3 and try to do shorthand. I don't know. It's like teaching me that. So if you look at these guys, we can answer these without having to go to factored form. Yep, sum is an even better word than addition.
But the next one be
Just wait, I'm going to get everybody refocused in here.
No.
Refocus.
What? I wasn't even doing that yet.
Damn it.
So if you look at the next 3 questions, we're going to try to go from powered form to 1 singular simple form without having to write it all out. So if you look at this guy, we have 2 to the power of 3, 2 to the power of 4. I could combine that to be 2 to the power of 3 plus 4. That means it's 2 to the power of 7. If you look at the next one, I have 3 to the power of 3 times 3 to the power of 2. I could combine that to become 3 to the power of 3 plus 2. That means 3 to the power of 5. My last one, I have 8 to the power of 3, 8 to the power of 1. That means I become 8 to the power of 3 plus 1. That's 8 to the power of 4. Our rule, when multiplying powers with the same base, add the exponents, add, and keep the same base. The base doesn't change. This rule is going to go on for all your life in math in high school. It's called the product law. Okay? Product means multiplication, so it's the multiplication law. And in math terms, you get this guy down here. Like that's like your formula. They just use letters instead of numbers. So they're saying if you have two bases that are the same, and you're multiplying, then you can add the bases to become 1 like that. A to the power n plus n. Yeah. Sorry? This is add. And I put a big exclamation mark because that's it.
But that means that's a sum.
Yeah. It's poor grammar. Fantastic. Here we have 10 questions where we're going to try them all together. You'll see they progressively get harder, and it will progressively get harder next year too. Okay, and Math 10C, like this is straight out of there. So if you ever go on in math, you'll be able to do this stuff no problem, as long as you practice. So the first question is 6 to the power of 3 times 6 to the power of 5. I have the same base. Both bases are 6. I'm multiplying. That means I can add the exponents to become 6 to the power of 8. Right? 3 plus 5 is 8.
Is this right?
Close. Not quite. If you look at B, the base is -2. That means when I combine them, my base should be -2. So I got -2, and then I add the exponents. 3 plus 5 is 8. The next one, I have 9 to the power of 4 times 9 to the power of 3. Bases are the same. That means I can add the exponents. It's 9 to the power of 7. Try D and E on your own, and then I'm going to show you how to do the ones with letters where it gets a little more complicated. So try D and E on your own. So if you look at D, you have a to the power of 4 times a to the power of 2. You're going to add the exponents to become a to the power of 6. For E, you have b to the power of 7, b to the power of 1. It's like an invisible 1. So it becomes b to the power of 8. These ones, I would generally consider them easier. The reason why I consider them easier is because the base is pretty straightforward. There's only one base in the question. Right? Like we never change it. It's always B or just A or just 9. Like it stays pretty straightforward. The second column gets a little more challenging because now you have multiple bases and you have brackets. People don't know what to do with brackets and it freaks everybody out. So if we look at F, what F is telling us is that we have M times n squared. That's what this guy is. And then there's nothing in between the brackets. You just have brackets against each other.
So it's multiply.
When you have brackets against each other like that, what does it mean to do? It means to multiply. So what it's telling you, I got you, is that you have m times n squared times m to the 4 n to the 6. If you were to write that out longhand, it looks like this. M times n times n times m times m times m times m times n n n n n and n. That's really what it's saying. I mean, that's a ridiculous way to write it, right? Like that's factored form. But that's what this means. With multiplication, you can reorder multiplication and it's the exact same thing. So I could reorder this so that all the m's are together and all the n's are together. And then what I really have is m 1, 2, 3, 4, 5 times. So I have m to the power of 5. And then I have n 1, 2, 3, 4, 5, 6, 7, 8 times. N to the power of 8.
So
And-
just 2 separate questions in one.
It's like 2 questions in one. And so what our rule is when you're multiplying like this, no additions or subtractions. You add the exponents for the bases that are the same. You won't need to put brackets around it. So if you put brackets, that's fine, you're not wrong. If you didn't put brackets, that's fine, you're not wrong. Okay, but all you need to realize is m's go with m's and n's go with n's. In the future, the way I'll refer to it, especially if you take math at a higher level with me, is I'll say numbers go with numbers, letters go with letters. The letters go with the same letters. And as you get going, it'll be radical symbols go with radical symbols. Radicands go with radicands. And we just keep building on this idea that you only can match up with what's the same. Yeah.
What's the yellow?
Yellow says n to the power 8. So if you look at G is the exact same concept with just more letters, right? We have A can only go with A's. That means I have A to the power of 4. B's can only go with B's. So I have B to the power of 9. And I have C's can only go with C's. That gives me C to the power of 6. That would be my, yeah, nice and colorful. That gives me my simplified answer. I'll try not to use the yellow anymore, sorry. It's really not that hard as long as you understand like some fundamental rules.
So with the next one, x to the power of 10.
Okay, so for the next one, you now have multiple x's. Instead of 2, you have 3. I'll put it back up there. Just give me a second. So you'd have 3 x's. So you're going to add all the exponents on all the x's. And you can see how these questions just can get bigger and bigger and bigger because it just means you have more of everything, right?
Will they get bigger and bigger?
Yeah, like when you get to math 10, you're going to have like big fractions with a bunch of sets of brackets. And you're just going to keep applying these rules to get it smaller and smaller and smaller until you have like 1 or 2 things together.
So it'd be x to the power of 10, y to the power of 7, and z to the power of 10.
Yep, this would be x's go together. 2 plus 4 plus 1 is x to the power of 7.
Oh, I was doing like, because it's 3, I was doing it instead of 3.
Ah, yeah, no, you got to be very careful on what the exponents are. The y's, we have y to the power of 3, y to the power of 1, y to the power of 3. That would be y to the power of 7. Z to the 5, z to the 1, z to the 4 is z to the 10.
So then it's like in one.
Yeah, I'll show you after.
It's x of y to the power of 3. Would you do x 3 times or just once?
For which one?
It's like in the last bracket, it's x y to the power of 3.
So that's because of the base. X is its own thing, and then y is its own thing. Yeah, so it would be x to the power of 1, y to the power of 3. Yeah, yeah. And that's where like identifying the base becomes very, very important. Awesome. For I and j, we just have fractions. So I would be 3 over 7 as the base to the power of 9. Add the exponents. For j, we have x divided by y to 2, x divided by y to 8. You would add the exponents. The base stays the same. You have x divided by y to the power of 10. Not bad, right?
That was pretty
X to the power of 1.
Also, I like how you switched it to 3. I like
That way you can see better.
would it be able, like, can you have an exponent? Or